Hi friends, welcome to follow-up. Let's have a look at problem 1123. Lowest common ancestor of deepest leaves. In this video, we're going to provide a solution based on traversal, and in between, we're going to use recursion. So here the problem is very simple. So given the root of a binary tree, so we are required to return the lowest common ancestor of its deepest leaves. So this problem is different from another leetcode problem, which requires to return the lowest common ancestor of two given nodes, right? So here we want to return the lowest common ancestor of all the deepest leaves. So here are three examples. So let's focus on example 1 because example 2 and 3 are relatively simpler. So in the first example, so the return is 2, right? So the reason is that, if you look at 7 and 4, so they are deepest, they are at the same level, right? So then their parents are the lowest common ancestor. So if we actually ignore the last level, that is the nodes 7 and 4. Then if you look at the tree ending at this level, 6, 2, 0, 8. And then 3 will be the lowest common ancestor of these 4 nodes. So the reason is that, here if we look at 3, so the left subtree and the right subtree have the same depth, right? So this one must be the lowest common ancestor. So similarly, now let's turn back to nodes 7 and 4. So if we check the root 3, and then we look at its left subtree and the right subtree. So the left subtree is one level deeper than the right subtree. So we move towards the left subtree. So now we at root 5. So if we look at root 5, and then we examine its left subtree and the right subtree, we notice that the right subtree is one level deeper than the left subtree. So we move to the right subtree. Then we arrive at the root 2. So now if we look at this subtree, so its subtree, left subtree, and right subtree have the same depth. So this node 2, or the tree rooted at node 2, is the thing we want to return, right? So in other words, for this problem, the main thing is we compare the depth of the left subtree and the right subtree, and then basically we want to find the highest level nodes which have the same depth left subtree and right subtree. So here in this problem, so the number of nodes in the tree will be in the range given by 1 and 1000. This is the two ends of the closed interval. It's relatively small, and the node value is in between 0 and 1000. So this is not very essential. Thirdly, the values of the nodes in the tree are unique, right? So here I'm going to provide a very verbose solution just to motivate you think. So basically I want to use this code to digest the logic. First, I'm going to write a depth function. So this function accepts a tree node, and it's going to compute the depth of the tree rooted at this root. So first, a special case or stop condition if not root. So we're going to return 0, right? And then if we have the left subtree, we know the left subtree and the right subtree depth, and then the original tree rooted at root will be the larger depth plus 1. So what we're going to do is we return 1 plus the max of, this is the self-call, and root left, and depth root right. So this is the utility function we're going to use. In other words, you put a tree node here, so it's going to compute the depth. And then basically we are going to do traversal, right? So here is a utility function just for digest the problem, so the logic. And then we are going to do traversal. So this is a binary tree traversal, right? So what we are going to do, we set the current to be the root, and then what we are going to do, while current, we are going to check the left subtree and the right subtree. So that is the depth of current left and the depth of current right. So first, if L equals R, it means that for the current node current, its left subtree and right subtree have the same length. Then the current would be the lowest common ancestor of all the deepest leaves. So we're going to return the current state. This is the one case. Another case is if the left set is deeper, like here in example 1. So we are going to move from 3 to 5, right? So basically current equals current left. Else, so the right subtree is deeper, so we're going to move to the right. So due to the fashion or the problem assumption, so finally we must have something returned. So this actually forms the full solution format or if solution format for this problem. Now let's first do a test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes the generic case. So now we finished one solution for this problem. But for this problem, as we mentioned, so we didn't use effectively this value, and the nodes values are unique, right? So we used here the number of nodes is not that large, so we can do this fashion. So there are a number of improvements or variants. Here, let me list several of them. So here, our strategy is using traversal, right? With the help of depth function. This is very straightforward. So another thing is that we want to stimulate you to think is that we need to think. I use this one. So use how to use this assumption, right? So for this, actually, because the values are unique, so actually we can establish a map between node value and its parent value. So this way, actually, we can write a iterative solution format. So this is the one extension. Another extension is the following. Let me write this as extra or extension. Another one is that so here we are writing into this format. So actually, if we set some variable, so local variable or global variable, and then we can write this depth function, and at the same time we are going to do the return. So in other words, we combine these two parts. That's called one. And another choice is that we combine the utility function and the traversal step, right? So this is also very straightforward to implement. So I guess for the purpose of this video, so I'm going to stop here. And then as for coding, we need to practice by ourselves, and we want to solve a single problem using different methods or variants, or we use different variants or methods to solve the same problem. Yeah, overall, so we need to practice more to better gain the intuition and again the logic. We'll see. That's about it for this specific video and problem. Thank you.